Hello, students, and welcome back to Fantastic Chemistry. I'm your teacher, Mr. Flynn. Today, we're going to be solving how-to problems with radioactive processes. In the previous video, we had more of an informative video about alpha and the two types of beta particles that are being released. So please make sure this card is in your notes and refer to this as we go through, as we solve these problems, because it will help you as we go through them, help you kind of picture what's going on. Okay? All right. So let's get started. So write out the equation for an alpha radiation being emitted from the isotope below. So uranium-35 is going to be our isotope of uranium that we're going to use. This uranium-35 was actually used in the Manhattan Project when America was developing the atomic bomb at the end of World War II. So let's write out how this isotope emits a alpha particle. So let's write this out. So uranium-235. Okay, and that's its atomic mass. Okay, its atomic number is 92. Okay, and an alpha particle is basically a helium atom. So it's going to a helium atom. It's got an atomic mass of 4, an atomic number of 2, and it has a 2+ charge. That is what an alpha particle is. Okay, just say that is what an alpha. I'll just point to it. That's what an alpha particle is. Okay, now what we have to do is subtract the 2 and the 4 from these numbers respectively. So if it's going to lose 2 protons, it's going to be now 90. But what's the element? It's at 90. That is thorium. Okay, it's going to be TH. All right, and then we have to subtract 4 from 235, which would be 231. And what we're going to show that we're losing this helium atom, we have to write it in the equation because mass is conserved. Okay, it's gonna be 2 positive. So that is how we would write out an alpha decay. Okay, so now uranium is turning into thorium, and it's releasing this helium atom. But fast-moving subatomic particle. Okay, now let's come down here and let's talk about the release of a beta minus radiation being emitted from potassium. Okay, so potassium 40. So I would write it like this: K40, and its atomic number is 19. Okay, now let's refer to our card again. In a beta minus decay, it's a neutron turning into a proton, releasing an electron. So if a neutron's turning into a proton, the mass number will stay the same. So it's going to be 40. Okay, but now our neutron's turning into a proton, so now we're going to have an extra proton. And what element is 20? Right next to potassium is calcium, Ca. Right, and it's going to emit an electron. Okay, all right, that's how you would write out that equation. The next one, oxygen 15. So let's write O15, and its atomic number is 8. Okay, I'm just showing it to you. And when we look at our beta plus decay, it is a proton turning into a neutron. Okay, so our mass number will stay the same, but our proton is going to turn into a neutron. So we're losing a proton in this process. So it's going to turn into a 7. It's going to -1. And when we look at 7 on the periodic table, that is going to be now nitrogen. All right, and it's going to release a positron, which is a positive electron, essentially. Okay, so we went through alpha radiation, beta minus, and beta plus, and we went through and wrote out the equations for each respectively. Okay, thanks for watching.